Hello and welcome to another episode of Nathan Builds Robots. Today we're going to be checking out the CR10 SE, which is a new printer from Creality. It's in the box right here, so let me just get it taken out and we'll take a look at it. Here's the top gantry, and then we've got the base of the machine. So it should be a pretty simple assembly. It comes in two pieces. There's just 4 screws to put this thing together. Just tighten up these 4 screws, and then we'll put this on over here. Oh wait, no, this is the Ender 3 S1 Pro. This is the CR10 SE. Okay, so I got these two mixed up, which is understandable because they're reusing a lot of the same parts. So what's the deal with this CR10 SE, and why does it exist in Creality's lineup of 3D printers? And also, why does it have completely different styling from this new and updated version of the Ender 3, the Ender 3 V3 SE, with its new aluminum extrusions in the back and much slimmer and sleeker design? Well, the way I like to think about it is this CR10 SE is just a continuation of the Ender 3 S1 lineup, but they've added a bunch of additional features to it to make it quite a bit nicer. So it might be worth picking up over the Ender 3 V3 SE or the Ender 3 V3 KE, which is the clipperized edition of the Ender 3 V3 SE. Alright, that took about 20 takes to get all the names right. So there's a lot of confusing things about this machine, like why do they call it a CR10 when really it's an Ender 3 format printer? So let's dive into this printer and learn a little bit more about it. The CR10 SE. The CR10 lineup from Creality has always been their kind of more professional lineup, and they've almost always come with a 300 by 300 millimeter bed. This is a strange departure to start using an Ender 3 format printer and calling it a CR10 printer, but given how overcrowded that Ender 3 lineup is getting, it makes sense that they kind of want to branch it out into something else. If they want to consult with me for naming their products in the future, just send me an email or something, Creality. I'm sure I could come up with something that makes sense. I'm going to put this Ender 3 S1 back up on the table just so that we can kind of compare and contrast these two printers and really show where they're different. Starting with the motors. If we look at these motors, you can see on the X-axis, this motor is quite a bit bigger than what we have on the Ender 3 S1. It's just, you know, a little bit bigger, a little bit more torque capacity, and that'll help handle higher accelerations. If you look on the Y-axis as well, you've got a similar motor upgrade. So take a look at both of these. You can clearly see that the Y-axis motor is smaller on the Ender 3 S1 Pro, and it's bigger on the CR10 SE. They use a different cabling system. I mean, they both have a nice strain relief, so they should be pretty much equivalent. They've changed from using a 24-pin ribbon cable to using a round cable that carries all the electrical connections up to this hot end. The Z-axis on both of these machines is pretty much identical, as is the injection molded base of the machine. Just looking at them, they're pretty much identical other than the color. If you look up front, the Ender 3 S1 has its inputs and outputs over here on the left-hand side of the machine, and on the CR10 SE, we've got a couple of USB ports over here on the side of the little touchpad. Probably the most significant and noticeable upgrade just by looking at these machines is that the CR10 SE uses linear rails for the Y-axis as well as the X-axis. And the reason you'd want to go with linear rails is just to make things stronger and stiffer. If we take a look at the Ender 3 S1 Pro, it's got bed leveling knobs down here. There's kind of this transitional period where printers are moving from being manual bed leveled to automatic bed leveled, and they have these vestigial bed leveling wheels, which aren't really necessary. As long as you have the bed at least somewhat level from the factory, that automatic bed leveling should be able to compensate for any misalignment in the print bed. On the CR10 SE, they've completely done away with the bed leveling wheels, which should help simplify setup. This is the highest end machine, and it's coming with the highest end linear motion components. It's using a really wide linear rail for this Y-axis, and you can see when I try to wobble this bed, it barely moves at all. Compare that to most other printers. When you wobble it, there's quite a bit of motion there, and you have to deal with these V-groove wheels needing to be tightened every now and then. Now, I personally don't think that's that big of a deal. I'm pretty well trained at tightening V-groove wheels, but that's a skill set that not everyone has. And having something like this with the linear rails will undoubtedly be lower maintenance and easier for beginners to use. You can also see a linear rail on the X-axis, and that just makes this whole setup incredibly stiff. You're going to have much more precise control over where this print head is because it's not going to be bending and wobbling around quite as much as a V-groove wheel setup would be. V-groove wheels, for all their benefits, they're extremely cheap. They help quiet the printer down because the wheels have an inherent damping property. And if they break down, it's pretty inexpensive to repair and replace them. For all those upsides, there's also some downsides like a shorter service life. They require more frequent maintenance, and they're not quite as stiff as a linear rail system like what we have on this newer printer. So you can rock this back and forth just a little bit. It's not enough to where it would really show up on camera, but you're talking about sub-millimeter amounts of deformation, and that ends up being significant on a 3D printer because the nozzle width is less than a millimeter, and your layer height can be as small as 1/10 of a millimeter, so even really small deformations can cause issues. Also, when you push a printer faster, you're dealing with higher dynamic loads, which will tend to rock this back and forth and cause slight amounts of inaccuracies as you're printing, versus on a machine that's much more sturdily built using linear rails, you have much less issues with that. Okay, so it sounds like the main headline feature for this thing is it's got linear rails, it's running Clipper, and it's got a new bed leveling system. Well, it's kind of a mix of a new and an old bed leveling system. So you can see here on the side, it's got a CR touch, just like a lot of the Ender 3s have nowadays. Even the Ender 3 V3 SE has a CR touch off to the side here, which it uses to build up your bed leveling mesh, but it also has a little load cell in the corner of the machine that it uses to calculate the Z offset. And that Z offset is a critical bit of tuning that helps the printer understand the height difference between the tip of the nozzle where you're printing and where that CR touch probe is. But that distance between the nozzle and the CR touch probe, that measurement is really critical to getting your perfect first layers, and that's where the load cell based automatic bed leveling kicks in. I'm trying to figure out where the load cell is on this thing, and I don't see it in the base of the machine, so it must be inside of the hot end, which is kind of strange. You would think that if you had the load cell, you wouldn't need the CR touch because you could just use the tip of the nozzle to touch everywhere. Yeah, that is pretty weird. Also, they've used to moving sensorless homing on this newer machine. On most of the older Ender 3s, you've got these little limit switches off on the edges that trigger, and that lets the printer know where the edge of its print volume is. But on this one, you've just got these little pegs. There's one right here, and there's one on the back of the printer that the X and Y axes just bump up against. Then your Z-axis homing is going to be done with a combination of this CR touch probe as well as that force sensor that's probably built into the tool head somewhere. So overall, it's a pretty nice design. Let's get it turned on and see how well it prints. Up top, we've got a nice little LED light that we can turn on and off. This is really handy for if you're printing in a dark room. We've got a nice little touch screen here. I'm going to set it up in English. I don't know if I'm going to go through this whole privacy policy. I'm just not going to use the cloud stuff, and I run my stuff offline, so it shouldn't really apply to me. Here's the little keyboard where you can enter your Wi-Fi password, so you don't need to use an app to do this. Although I gotta say, this keyboard layout is pretty annoying because it's not an ABC order. Then right here, there's an option to bind your device to the Creality cloud. I'm going to skip that step because I'm not really interested in using cloud features personally. Just like that, we should be good. So this process is expected to take around 11 minutes. And while this is running, let's just kind of see how that automatic bed leveling procedure works. One of Creality's big efforts in their new lineup of printers is to simplify the setup and bed leveling experience, going as far to completely automate it on most of their printers. So you're not having to worry about bed leveling knobs or setting the Z offset or getting a piece of paper out. Ooh, and there's our first moves. Okay, now it's touching down into the base of the machine, and I wonder where the load cell is. It's definitely bumping the nozzle against the bed. Wow, there's a fan that's kind of loud. I just went in the other room, but let's take a listen to this. That's generally not what we like to hear, and I can feel the vibrations on this tool head. They've got an extremely powerful fan running there. So yeah, part cooling fan probably won't be lacking on this machine. That's something that I always complained about on a lot of the stock Ender 3s. They come with a little 4010 part cooling fan. On this one, it seems like we've got a very beefy, powerful part cooling fan. And now I'm complaining about the noise. So, oh my goodness, this thing is loud and fast. I'm a little bit scared of it now. And we've got an issue already with the cable management. You can see back here, this cable was touching the bed. I guess it'll touch the bed again, and it might actually get caught. I'll see if I can just throw an additional zip tie on here to get this to be up and out of the way. Something like that should do the trick. So is it just me, or does this thing sound extremely fast? Alright, well anyways, let me fix this up with a zip tie. I don't want it to have any issues with that, that little cable back there. This begins our input shaping. It's just going to jostle back and forth a little bit so that it characterizes the resonant frequencies of this machine so that it can cancel those out and basically produce crisp corners on prints while the printer is running very fast. This is something pretty much any high-end printer does nowadays, so it's nice to see here. Oh, there we go. It's done. So notably, it did not do any input shaping on the y-axis, which is a little concerning, but we'll see how that works out. Now, theoretically, you can assume that the x and the y-axis behave similarly if they're of similar masses and are driven by identical motors and belts. But if you're going for like rigorous mechanical engineering, you're going to want to do that x and y-axis separately. But we'll see how it affects print quality, and let's get on to the next phase of the test. So on this screen we can see a similar display to what we saw on the Ender 3 V3. It looks good. I like the interface. It's functional, does all the things you need it to do, and it allows you to interface with Creality Print, which is their kind of print farm management app that lets you load up jobs to multiple printers and lets you slice stuff. Now the only thing I have against it is it's based on Cura Slicer, and I have a prejudice against Cura Slicer, but I have to forgive that for now. Now I forgot which one of these flash drives came with the CR10 SE, so let's just plug them both in and see what happens. Now I kind of like their decision to have the flash drives mounted to the actual touchscreen interface, because if you have this set up in a cabinet somewhere, you could move this little display somewhere else, or maybe you could even get an extension cable and like have it all in one central area where you can manage like 4 different printers on a table from one little spot. That's pretty cool. And you know, this is a good old sprite extruder, something we're very familiar with on this channel. So we shouldn't have any surprises there. The one thing that is surprising about this though is that they reversed the orientation of the sprite extruder. Now I did like this weird rant video where I pretended I was a private investigator investigating the sins of the designers of the Sprite hot end and saying that they put it on backwards. Well, they finally righted that wrong and they've flipped it back around, and now everything's packaged on here more compactly. I don't know if my video is what prompted them to make that change or if it was what they were intending all along. But in any case, it's cool to see. Now, let's see. I'm going to take this front shroud off just so that we can see what's going on in here. Alright, so if we take this lid off, we can see our little blower motor here. This is a 24 volt 300 milliamp fan, so that's quite powerful, and that's directing all of that air into this small little area. Let's see what's going on with the tool head though. Okay, so it looks like we've got our Sprite hot end, and this is the die-cast aluminum version. Here's the load cell. It looks like they replaced the heatsink module that was on the Sprite extruder previously, that slotted in right here, with a load cell module. So now there's a load cell here, and they've bolted a little heatsink onto this with a little fan and our hot end. And the hot end that it's using looks identical to the one that's on the Creality K1. So that should be a volcano length nozzle with a lot of melting capability. So here's our little breakout board with what looks to be some kind of input, you know, a little microcontroller that is then controlling everything else on the hot end. It's a lot more complicated than their previous breakout board. This is a true mini control unit down here, so cool stuff to see. The way that they've packaged this is a little bit different than their previous editions. It looks like they realized there was some opportunity to have the stepper motor hanging out on this side on top of the rail. Overall, a pretty good design. Although I'm still confused why Creality is falling back on the CR Touch. You know, they're using these CR Touches on everything instead of just relying on the load cell bed leveling. Maybe they found that this CR Touch was actually slightly more reliable, and then they used the load cell just for calculating that offset, but I don't know what the deal is there. On the Creality K1, it seems to work fine just with the load cell-based bed leveling. Anyways, let's get this put back together and we'll start up that print again. Everybody knows that most printers can print over USB, except for Bamboo Lab printers for some reason. Might be that they're trying to force you into cloud usage, but anyways, I digress. Let's get this fired up using my local Wi-Fi, which is not connected to the internet. Alright, so I've worked with Creality Print before. It's pretty nice. I've just got a couple of things loaded up to print here, and I'm going to add printers. Let's see if the CR10 series is here. Doesn't appear to be loaded up at the moment. Not any of these. Oh man, the CR100. I want one of those. This looks awesome. Oh, the CR1000. Let's get one of these in for review. I haven't updated this since they added the CR10 profiles. I'm guessing I need to download the latest version of Creality Print to get this to work. CR10 SE, there we go. Add 0.4 nozzle diameter. Now let's load up our models and print that again. I threw in a Benchy for good measure. Model has not been supported and may fail to print. Nah, we'll be fine. I always design my models so that they don't need support material. Well, almost always. Okay, so let's do some LAN printing. I'm going to need to switch back to my internetless Wi-Fi network that I use. I don't need these printers talking to anything but me and my local network stuff. We don't need them phoning home to Creality HQ or Bamboo Lab HQ or wherever else. I take network security somewhat seriously, I guess. Anyways, let's export this to, using LAN print, confirm. We'll select this, and we'll say send G-code. You can do one-click printing if you want, but I prefer to do send G-code and then start the G-code on the printer itself, just because that gives me a little bit more control over the process. Well, let's just go ahead and print this one out, turn off the calibration because it's already been calibrated, and we'll hit print. So the cool thing about this Creality Print software is if you have a bunch of printers, they'll all pop up on this list, and you can manage print jobs on like 10 or 20 machines or however many you have. In this case, I just have one machine hooked up to my network right now, so just one is showing up. But I've had multiple Creality K1s on my network before, and I was able to see them both and manage their print jobs, and it was pretty convenient. We can also go to this details page, and this opens up a tab here, and it allows us to monitor all of our print settings. Now this is Fluid, as you may be familiar with it. This is that open source Clipper software, and Creality is finally starting to release the source code for their stuff. They were a little bit late to doing that, which is a little bit bad, but at least they're starting to share their code, and I think they fully intend to. For a machine at this price point, I expect it to work reliably without fuss. In terms of filament, I'm using some stuff that Creality sent me a while back. It's Silk PLA. That's like this multicolor rainbow stuff. And you know what? Actually, I hate Silk PLA. I think the world would be a better place without silk filaments, because they have worse mechanical properties than regular filament. I'm actually going to print with this blue Hyper Series PLA from Creality. They sent it to me a while back, and I figure we're printing on a Creality printer, we might as well print with the Creality filament. Plus I do like this color of blue. Looks very nice. And the filament runout detection sensor is doing its job. I said the filament is running out, printing is suspended, please replace it. So yeah, I'll replace it. We've got some black filament. That means they did run some quality control on this machine. Hopefully they do that for all the printers they ship out of the factory, because that helps catch just small little mistakes. I think we're ready to print. We'll watch it start up at least, and then we'll switch it into time-lapse mode and just, see what this puppy can do. But I do like how Creality is using the Clipper, Fluid, Mainsail, whatever interface. It's really nice, and you can even open this up in a web browser. You just have to enter this IP address up here into a web browser, and you can check out all the information while it's printing. That way you don't have to download Creality Print if you don't want to. You can just open up a web browser and drag and drop files into your printer wirelessly. pretty convenient stuff here. I just wish Creality was a little bit better about upholding their end of the open source agreements and licenses for software that they're working with. I think overall Creality is pretty good about giving back to the open source community. It's just, it spreads a lot of bad will when they're not releasing that source code immediately. Clearly they have the source code because they've produced the printer and the firmware and they have the software interface. So just releasing that firmware, I think, is something that they need to work on doing in a more timely fashion moving forward. Okay, so now that we've got this new filament loaded, let's fire up this print job again. We can just click Start Printing here. This is laying down the first layer quite fast. Normally you see the printer moving super slow for these first layer moves. That's not the case here. It's going pretty rapidly. But yeah, we're printing away, so as is tradition on my channel, I need to do a decibel test. We'll see how loud this thing is. So here's my decibel meter app. We're about an arm's length away. Looks like about 45 or 46 decibels. Currently, I mean, it's not running its part cooling fans yet, so once those part cooling fans kick on, we'll take another measurement. The hot end cooling fan is quite loud. You know, most printers have a hot end cooling heatsink, and that can be kind of a source of noise. It's a little bit of an irritating tone. I'll let you listen to it. I think it would serve Creality well to use a larger heatsink and fan that's a little bit quieter, because I like my quiet printers. This first layer looks a little under extruded, or maybe the nozzle's just a little bit too high for this first layer. So I might want to go in and tweak the Z offset a little bit. There isn't a place for me to make that Z axis adjustment as far as I can tell. So if we look over here on the slicer view, maybe we can make an adjustment here. Now this is where it would be nice if Creality was just running stock Clipper instead of making their own version of whatever this is. I think the reason why they don't use stock Clipper is because Clipper might push an update, or, you know, as they update the software, it might break compatibility with old things. So Creality wants to have their own stable version of this that they can use without having to worry about things going down. But it is a little frustrating to see little bits of functionality removed from the printer that are there in the base software that they're starting with. Though I will admit that I usually err on the side of everything being too squished to the bed, and often I'll have parts stuck on way too well. So maybe this is their way of managing that and making sure parts don't stick too strongly to the bed. But anyways, everything's printing fine. Let's just give you some close-ups here so you can see what's going on. Ow. So as you can tell, the part cooling fan on this thing is quite loud. I have no idea why they do this. You know, I just want to have a quiet printer. So again, about an arm's length away, 57 decibels. That's pretty loud. I don't know. It's quite loud. There's got to be a way to quiet this thing down a little bit. Oh my. And that's only with the fan speed set to 50%. Let's see what it's at when it's at 100%. Oh my gosh. I don't think it's much louder than 57 decibels. Yeah, maybe 1 or 2 decibels louder. Oof. Even at 20%, this fan is quite loud. Well, that's about as low as we can get the noise with that part fan on at all. They really need to put some quieter fans on these things. I mean, this is just silly. But yeah, we'll just leave it at 50% for now. This is the user experience as Creality intended. But anyways, I think it's time for time-lapse mode.
What?
Alright, now as this print is finishing up, let's get into my final thoughts on the CR10 SE. But first, let's take a look at this print quality. A textured PEI sheet is something we've come to expect from most printer manufacturers, just because I feel like it hits that balance between reliability and ease of part removal. And this seems to be a really well-designed sheet that holds onto the parts well enough. But overall, these prints look quite good. Let's get some close-ups of this benchy, and you can see how it can reproduce really fine details. These bottom layers look pretty good. Some of this text is slightly hard to read, so not a perfect result here, but pretty typical from most machines that I've looked at. There appears to be a little bit of a shifted layer right here, but that was when I was tipping the printer, and I think it might have maybe messed it up in that small area, so we won't hold that against it. And looking at it from this view, you can kind of see how it's dented a little bit, but I was definitely messing with the printer during that part. However, the rest of this doesn't look super clean. Especially if you look at this surface here, you can see it looks like it's dented inwards a little bit for this text. And then right up above and below, it's slightly bowed outwards. And you can see the same sort of thing happening on this little area with the text and where this name is. So there's something strange going on there. Most of these straight lines look really good. In terms of its retraction performance, it performed quite well there. You can see there's minimal stringing, and whatever stringing there is, I can easily just clean that up with a blowtorch. On these little parts where it's supposed to be testing the bridging, well, the bridging performance was quite good. You can see all of these little bridges turned out quite nice. But on the top, you can see some evidence of slight under extrusion there. And that's kind of present on a lot of the models that I just printed. Here on this benchy, you can see slight gaps in between the perimeter layers, and you can also see it kind of on the back here of this benchy. Not sure how well it's showing up on camera, but you can definitely see the lines aren't coming together perfectly. They are coming together in other areas, it's just right there, it's a little bit under extruded. Maybe this printer needs a little bit of flow tuning, like pressure advance, and that's apparently not something that it does out of the box. It looks like we have good overhanging performance up to 50 degrees. Anything beyond that, it looks like there's slight little bits of, like the filament is drooping down and it's not printing perfectly. So, small issues there with overhanging performance. I mean, the bare minimum that a printer should have is the ability to produce a 45-degree angle, and preferably I like to see printers that can do 60 or 70-degree angles, because that just allows you a lot more freedom and the ability to print without supports in a lot more scenarios. But all of this text looks pretty good. It's just these layers don't look like they're perfectly stacked. And part of the issue might have been that it was printing multiple objects. So it was going to print another object and then coming back to this one, and maybe it didn't index back to the same location perfectly. And again, up here you can see there's a little bit of evidence of a little bit of flow tuning that needs to occur to help get the best results. But overall, when you look at these parts from a distance, there's nothing wrong with them. I don't think anyone would really have much to complain about if you were printing objects and they came out like this, but at the same time, it's not perfect print quality. Alright, so where does that leave us with this CR10 SE? Well, in my opinion, it's not representing the best value. I think this is actually a great opportunity to talk about one of Creality's other products, which is the Ender 3 SE. This has the same general specs and construction. It's got roughly the same build volume, it's easy to use, but this comes in at an incredible price of $199. So at that sub $200 price point, Creality has produced a really good printer for that price point. This Ender 3 V3 SE is a really good deal. Also, there's the Ender 3 V3 KE, which is the clipperized version of this Ender 3 V3 SE. And instead of having this little dial wheel knob thing, it's got a similar display / control system as this CR10 SE. So, I mean, if you're thinking about getting a clipperized Ender 3 style printer, I would really steer you more towards the Ender 3 V3 KE, which is the Clipper edition. You're basically taking the brains and the smarts off of this printer and putting it on this lower budget printer. And I think that's retailing for $260 or $280. So a clipperized Ender 3 for $280-ish, that makes a lot of sense. What doesn't make as much sense is this CR10 SE coming in at a retail price of $460. So for the price of one of these, you can get roughly 2 clipperized Ender 3s in the form of that Ender 3 V3 KE, and that's really what I would go for over a machine like this. Now, don't get me wrong, this is a really nice machine, but I feel like it's a generation behind in terms of technology, and they're trying to brute force performance by slapping bigger motors on there, more precise and stiff motion systems, and a better control board. But it's really a last-gen product that is kind of being bootstrapped into being kind of competitive in terms of features in today's market. It ends up kind of driving the price of the machine up, and you'd be much better served by an Ender 3 V3 SE or an Ender 3 V3 KE if you want a clipperized bed slinger. So ultimately, this is the printer that I'd recommend to an absolute beginner or someone with a very small budget that wants to get into 3D printing. I think this Ender 3 V3 SE makes a whole lot of sense. If you're running a print farm and you want to be able to manage all of your printers using that Creality print interface where you can see all of your printers loaded up on the same screen and issue out print jobs and control them from one central station, then you're probably going to want to get a clipperized version, or Creality clipper as I like to call it, of their products. So that would be this CR10 SE or the Ender 3 V3 KE, which is their clipperized version of this. I think that's going to be the one to beat, and it's going to be the optimal price point to performance ratio for a semi-professional user. This printer, since it runs on a version of Marlin, it's much more basic and bare bones and cheap. Like, that's a really good thing to be able to introduce someone into the hobby. But if you were running a print farm, for example, and you had like 10 printers you wanted to keep running, you definitely want the clipperized version of this just to get a small bump in speed, but you also get really good control and management over those printers. So that will ultimately save you a lot of time. Also, Creality is coming out with the Ender 3 V3 with no suffixes. I know it gets really confusing with all these add-on letters and words and different models. But the Ender 3 V3, just Ender 3 V3, that's supposed to be very fast, and it's basically going to be a Creality K1, but turned into a bed slinger. So they're using a Core XZ motion system, which is a really kind of more uncommon configuration. Personally, I think that people don't use that configuration because it doesn't make the most sense. But I think it'll still be very interesting and should be able to print very fast. And that one will also come with the same type of interface where you're able to control it through Creality Print. So really, I think this is the least competitive printer in Creality's modern lineup. I'd really like to see the Ender 3 V3 and the Ender 3 V3 KE because I think those will offer much better value while having most of the same features as this machine. I should also point out that the print quality on this thing is actually quite good, especially for being able to print with these qualities at these speeds. Just take a look at this. I'll bring it close to the camera one more time so you can see. One of the hallmarks that I use when I'm looking at benchies to see if a benchie was printed precisely and accurately is how distinct this kind of hull cap is. You know, this little area where it's it comes out a little bit. On printers that are very precise and stiff, this won't be smoothed out. It's like a very sharp crease in there. And you can see on this printer, it was producing these details with a very fine level of precision. But then on the rest of these prints, you've got minor issues with a little bit of under extrusion, not the best overhanging performance, despite this fan being extremely loud and powerful. When you take those prints and compare them to something that was printed on a Core XY printer, like your Creality K1 or the FlashForge Adventure 5M or the Bamboo Lab printers, the P1P and P1S, those printers just have a higher level of precision. I mean, and just take a close look at this and you can see what I mean. Just look at these layers. These are perfectly stacked one on top of another. There aren't huge issues with under extrusion artifacts on the top layers, and it's just a really nice print result. And then you take a look at what we've got coming off of the Creality CR10 SE. You've got a little bit more ringing, a little bit more inconsistent layer lines. There's just some slight issues overall that hold this back from being the ultimate print quality. And this was printed on the FlashForge Adventure 5M. I did a review video on this machine and I really liked it, so if you want to check that one out too, I'll leave a link up here. Anyways, this thing is really well built. Everything on here is relatively stiff and strong, and I think they did a pretty good job taking the Ender 3 S1 architecture to its extreme. But ultimately, these newer Ender 3s just make a whole lot more sense. So, at the end of the day, I would just stick with the Ender 3 lineup. That's offering you the best price to performance ratio, and those printers are just, you know, they're just good. I think if they just scaled the speed back a little bit on this machine, then it would probably be producing really good print quality results. But in an effort to chase the absolute highest speeds, I think they've kind of missed the mark in terms of print quality a little bit here. Wow, actually, I just looked on Creality's website and they're already discounting the CR10 SE. So right now it's on sale for $386, and that makes it a little bit more competitive. I mean, at the $460 price point, I don't think it makes a whole lot of sense. But if they keep cutting that price down and you can find it on sale, then it could be a pretty decent printer. Just going up through the lineup, you've got the Ender 3 V3 SE, which is $199. Then you've got the Ender 3 V3 KE, which is the clipperized version of this, and that's like $260 or $280. And I think that's probably going to be your best price to performance. Then one step up from that, you have the Ender 3 V3 with no suffixes, and that's going to be the version that's using Core XZ kinematics, which is kind of a novel system. That one's going to be at the $360-ish price point. And then you've got this CR10 SE at the $460 MSRP. You know, it'll probably be discounted below that, but I don't think it deserves to be the most expensive machine on the list. Whew, it's just kind of a bit of a doozy. Yeah, I guess we'll leave it at that. I'll leave a link in the description below to all of these Creality printers, as well as some other really good printers in that price point. And ultimately, I would probably recommend the Ender 3 V3 KE, which is the clipperized version of the V3 SE. That's going to give you that nice web interface, but you're also going to have the low-cost construction that's going to be really nice and just simple to use and inexpensive. So, I mean, that's what we all want, is just a printer as cheap as possible that does what we need it to do. Okay, well, thanks for watching this episode of Nathan Builds Robots, and I'll see you in the next one.